Let me just quickly share this slides. So in the first module, we had discussed about semantic models. So what are semantic models and all? So I told you that there is something called as like semantics. Semantics means the meaning. So whatever exists, we see various kinds of data in this world, but they don't have they all the datas don't carry information. So we need to gather information by merging the data. So that is after merging the data, we can get some information, and that is called as semantics. Semantics means basically the meaning of the model or data, whatever we look, that is called as semantics. So this semantic thing, I gave you this example. Suppose you have two different sites. One site contains information regarding the Oscar winning actors, and every other information like when did he start the star started acting, when what for which movies he or she got the national award or the like Oscar award, what are the like different all the details are there in one particular site, and another site contains only the biographies of the stars. So obviously we can merge these two sites or these two data by if the name like attribute which we talk about, that the name of the star is common between both the sites, then obviously we can merge both the information from both the sites. That's called like integration, data integration. And if we go for that data integration, then semantically we can get some more information. Like semantically the data becomes more relevant. So this is what we discussed about in the previous class. So I just told you that that is because of the semantics, there is interoperability, means between both the data, like whatever data you can interoperate between them because both of them contain information regarding the same thing. Then obviously there is data integration and data abstraction. So how this the semantic concept gets used in your IoT domain? Suppose you that day I gave you one example, like suppose you are returning from your office through car by your car, and you order your AC to switch it on at suppose 24 degrees temperature. So automatically the information will be shared with the fridge, the TV, the lighting system, the security system of the house. Everywhere the information will be shared that the owner is arriving in around 5 minutes. He has already advised to keep the AC at a particular temperature. So accordingly, obviously the everything will be saved in the information, the IoT memory, that the owner likes the room lighting at this particular time of the day. This he watches this particular show on the or this particular web series on the TV, and he wants to drink this juice at this particular temperature. So every information will be shared with all the devices. So accordingly all will be taking their necessary steps. It's not that the owner will inform the fridge that I am coming, keep the juice ready at this temperature, I am coming, keep the lights on at this temperature for the lighting system. So it's just that single information will be shared, and every other devices in the ecosystem will be automatically triggered to take the necessary action. So that is like you go for data integration among the devices, and all these things like we discussed in the previous class. So I told you because this semantics, like we try to infer some meaning from the data whatever we have, that is only possible because of something called vocabulary and ontology. So what is that ontology? Ontology, I gave you that example of crane. So in crane what happens is depending on the context the meaning changes. So it might be like a single the crane. If I talk about a building construction site, obviously I am talking about the heavy vehicle. But if I have gone to a scenic place and I talk about cranes, so obviously you will understand I'm talking about the bird. So depending on the context, the vocabulary might be same, but the ontology changes. Okay. So depending on context also our semantic meaning varies. So all these things we discussed in the previous class. So now let's move over to the next part. So this also like we had discussed. So why we go for the semantic models? So I just gave you some examples. So this is, there's something called as the semantic model. Like whatever I told, like we try to infer the semantics meaning of the model. So how that is possible? Through the data, the whatever model we that is possible only because of these three kinds of representation if we go for. So what are these? One is relational model, hierarchical model, and a graph model. So you can see in hierarchical model, we see it is just a hierarchical approach. Okay, just top-down approach. There is no leaps at the same level. Okay, just one here, then next here. This kind of hierarchical model. So I'll give you examples specifically why how this models gets used. And this is a graph model. Graph model means from this particular point you have these kind of like multiple paths exist. Okay, and then a relational model. Relational means one relates to the other, this relates to this one, so one is related, one like step is related to the other steps. So that's how it goes. Then what are the different models that I told you? So this hierarchical model, as I just made it clear that this is a top down kind of like bottom up approach or a top down approach, where similar models have similar limitation when it comes to real world updates and are not very flexible when it comes to trying to traverse the model horizontally. So it is not possible to traverse horizontally in case of hierarchical model. It is always a top-down approach. So that is just there are some theories which I have given you. So why, like where this model gets used? So suppose generally now when you see, suppose you are hearing some music in Spotify or somewhere. So what happens is whenever you are listening to a particular genre of music, suppose you are liking the like Sufi music or the like rock music or whatever it is. So depending on your choice, you get suggestions that because you like this music, you might like this one. Like suppose in Netflix also, if you watch a particular web series, or in Prime also, Amazon Prime, you look watch a particular series. Accordingly, depending on your choice, they'll give you these like movies of or the web series of that genre. So that's what happens in this kind of modeling. So this is very common. Like you might have seen, since you like this movie, you might like this. So there is a you might like or like tab in all the platforms which will look now. So these kind of concepts get used now. That is because they have this, they follow this approach, graphical approach. Let me tell you this graphical. So suppose you saw, suppose what you say, suppose Badlapur movie you saw. Okay, so depending on your choice, they'll give you choices like either you see Gangs of Wasipur or Mirzapur, those kind of like, or like those kind of suggestions will come depending on your choice. Suppose you are more into the romantic genre, then accordingly you will get that get these kind of Fault in Our Stars, then all those kind of movies you will get. So depending on your choice, the graphical models take a decision, and that is getting implemented now in IoT also. Because depending on your choice, suppose whenever we search in Google also now, suppose you had gone to a particular restaurant during your birthday time or somewhere, and if you liked the food, you rated the food good, so obviously you will get suggestions based on, next time when you go for searching nearby restaurants, you will be getting suggestion based on your previous choice, that you chose Chinese that time, so these are the nearby Chinese restaurants. Are you understanding what I am saying? Yeah, hello. Yeah, is it clear? Kasam
Yes,
Sai
ma'am.
Vatan? Okay. Okay. So this is what is happening. So we follow all these models in your IoT also now. Okay. So hierarchical, all those models. Next comes the, as per your syllabus, we have something called information model. Okay. So I just, before I begin this, I want you to understand the difference between data and information. These are completely two different concepts. Okay. So now let me tell you what is data. Can anybody tell me, is there any difference between data and information? Anyone? Can you think of and tell me? Aditya Bajpayee, can you hear me? Aditya,
Yes, ma'am. Yes,
okay,
ma'am.
can you differentiate between data and information? Any idea? Are they same or different? Yeah, yeah, yeah. Hello.
Ma'am,
Yeah.
data is like a ma'am raw material, ma'am.
Okay. And information, is it a processed one?
Ma'am,
Or,
that ma'am
It is a
information something
processed
like
form of
that has
data, ma'am.
multiple meanings.
oh, yeah, yeah. Okay, so whatever he's suggesting is correct only. So what is happening is, suppose I tell you that today in Delhi the rain is suppose in 91, the suppose in 2020 the rain was suppose 15 centimeters or 15 inch or whatever it is, centimeters or millimeters. That was the rain, 15 millimeters. Then in 2019 the rain was suppose 50 millimeters. Okay, this is called simple data. Okay, but now if you try to plot that data, okay, and see, try to like infer that because of global warming and all, the ice are melting, so obviously like the water content in the river is increasing, rain is every all the weathers are affected. That means you try to infer something from the data, that is called as information. Whatever Santanu suggested, that is processed data is called information. So if you go about processing that data, it becomes an information. So this information model which is there in your syllabus, so before we go into this information model, just understand what is that. So obviously this is a superior version of the data model. So we will first go into data model, then we'll move into the information model. Okay, so what is data model? Data means obviously you know any form of raw form of information, the data whatever you get is called as data. Like any raw content is called, can be considered as a data, and if you can infer something from that data, it can be considered as an information. So this information model, this is a superior version of the data model. What is it? It is a in software engineering is a represent. This is the concept of the Wikipedia, which I am giving you right now, is a representation of concepts and relationships, constraints, rules, operations to specify data semantics for a chosen domain of discourse. Okay, these are the theoretical just concept. So you try to understand. It is representation of concepts, relationships, constraints, rules. So all these things about the data, if it is represented properly, it becomes an information. That's what it says. Okay. So let me not try to jumble up within this. What is this? Just try to understand that in the information is a superior like processed form of data, and model means you will be representing that. A model something means you need to represent, like able to represent it in a proper like form. Okay, so this yeah, in this information model generally can be is possible because of this. Either you use a UML or a entity relationship model or XML schemas. Okay, these are the approaches using which you do the information modeling. So next comes what is data modeling. This is the first thing which you need to know before you get into the information model. So data modeling means obviously data is any raw form of any content can be considered as a data. So how to model that? Okay. So there are basically two types of data modeling techniques. One is your UML, that is Unified Modeling Language, and the ER model or the Entity Relationship Model. So these are the two data modeling techniques. How you model the data. This is UML and ER. Next comes why we need to use data model. Data is anyway raw. Any raw content can be considered as data. So why do we need to go for the modeling of those data? That is only because if you model something, no, you won't be missing the data. Suppose what happens is ensures that all data objects required by the database are accurately represented. Omission of the data will lead to creation of faulty reports and produce incorrect results. So if you are like representing something, you will match and see that for every year I'll get this. Suppose in Delhi last year this was the rain, this year this is. So obviously if you tabulate that or put it in a graph, you will realize that for suppose 1999 or 2000, but that particular year you missed the data. If you don't put it in a tabular or a graphical form, it will be really difficult to make out from the, like if it is written as a paragraph, you won't be able to realize which data is missing. So that avoids data missing and omission of data. So it helps design the database at the conceptual, physical and logical levels. What are those? I'll tell you. So then helps define the relational tables and all the primary foreign keys stored procedures. I will proceed as we know. So it is also helpful to identify missing and redundant data. That is the main concept. Just keep in mind. So that's why we go for that data model. So what are the three types of data models? One is your conceptual data model. Next is logical data model and physical data model. So conceptual means the first thing is what is that model, what that system contains, that like question answer to this what is dealt by this conceptual data model. Logical means how it is done, how the how concept is answered by this logical data model. But the only thing is there is this model is typically created by data architecture and business analyst. Okay, what is here? No DBMS is followed. Logical data model means you answer the question how that is being, how that data is created, like how the rain is increasing. That's why how you pay. But next is it doesn't consider any DBMS, database management system is not at all considered in logical model. But in physical data model, what happens is you again answer that how this thing is happening, but you follow certain DBMS architectures and model approaches. Okay, that is the only difference. So let me just tell you, one is logical, then physical, and this conceptual. These are the three data models. So here in conceptual, you use the data and all. In physical model, all these concept, technical requirements, performance requirements, everything comes into place. In logical, your all the data will be coming and you answer how the things are happening. So conceptual model, let me just give you one simple example. Suppose you are creating a business where you have two attributes. The word I am using, just be careful about that. I am telling two attributes. One attribute is your customer. Okay, the second attribute is your product. Okay, so you are talking about two attributes and sorry, two entities, not attribute, sorry, entity. So one is your customer entity, the other is your product entity. So for the entity customer, what are the attributes? Attributes means properties. So what are the properties? You can go for the customer name, customer number, all those details. For the product entity, what can be the attributes? The product name, product price, all these attributes. So the relationship between these two entity is established by this sale. So this is called as a conceptual data model. So what happens in conceptual data model? So there are three things which like which it involves. One is your entity, then attribute and relationship. So what are these entity? Entities are customer and product, attributes are its names, and the relationship is the property. Okay, there this same. So this is about the conceptual model. Next comes the other model, that is the data model, logical data model. So the same concept, whatever I told you, that same example. Now just see, the entities are customer and product. The attributes are same, customer name and number. Can you look at what is the difference? Identify what is the difference between this model and the previous one. Just look at these two figures. Here, this is a conceptual model. So this is the diagrammatic representation. Now look into this logical data model. Can you find out the difference? Yeah, anyone? Hello? Yeah, can anybody identify? Amartya, can you hear me? Hello? Amartya, can you hear me? Ashish Kumar, can you hear me? Ashish Kumar? Yeah, Ashish Kumar, can you hear me? Ashish Kumar? Ashish Kumar.
Yes, ma'am.
Hello.
Hello, ma'am. Hello, ma'am. Am I audible?
Yeah, you are audible. Yeah, Ashish Kumar, can you spot the difference between this conceptual and logical model? Just see, look at this diagram. This is the conceptual model. Okay, the customer and product are two entities. Okay, and the attributes are customer name and customer number. For the product, these are the attributes. Okay, they are established by this relationship sale. This is a conceptual model. Next, move over to this logical model. The attributes are customer and product. Entities are customer and product, and these are the attributes. So, is there any difference? Can you identify between this and this one? Can you see the string over here written? Hello?
Yes, ma'am.
Okay, what is the string? What is the string? Anyone? You are aware about data structures, right? Strings. Hello? Let's look at this. Okay, here the entities are customer and product, and the attributes are its names. Okay, this is a conceptual model. But in a logical model, what is happening is here is a customer, here is a product. The attributes are also exactly same, but you like impose a constraint on the attributes. What constraint you are imposing? You are imposing that this has to be a string. Okay, are you able to understand now? Can you find out the difference? Whatever I am saying, you are imposing a constraint that this attribute has to be a string in both of them, and this attribute has to be obviously a number. Okay, because you are talking about the customer number or the product price, so this has to be an integer. Is it clear? Whenever you go for writing a code or something, theory is speaking in theory is different. In theory you will tell that the customer number and attributes, all these things you can tell, but when you actually go about writing the code, you have to specify the constraint that this particular, the name has to be a string or the character, the number has to be an integer. Do you do that or no? Hello.
Yes, ma'am.
So that is what is the difference between a logical model and a conceptual model. In conceptual model, you don't impose any restrictions. Okay, but in logical model, what you do, you go about imposing the restrictions in a logical way. Okay, what is the logic you are using? Obviously, the customer name has to be a string. String means like list the characters. Okay, group of characters. Okay, and similarly, this is the constraint you impose. So this is a logical model. Next comes a physical data model. So what is a physical data model? For the same set of example, suppose this is the customer and this is the product. The customer name, customer number, it is a variable character and integer. This is similar to the logical model, but here what you are using, a primary key customer number. Okay, and here a unique key product name. So that's what you give, like a specific key or a specific id you give to each customer, and specific id, like every product whenever you buy from a mall or somewhere, they have a specific qr code, so that is specific to that particular product. So that is the different, that is a physical data model. But where what you do is, here you go about like I giving a specific unique id to each customer and unique id to each product. Okay, so here all those concepts of your dbms will come in again, like all run all the database management like system, whatever concepts you use, everything gets used here. And here remember that you get this concept of key. Okay, the unique id or the primary key, unique key, all these concepts come in physical data model. So all the characteristics have been given here, you can anyway go through these slides. Then advantages of this data model, as I told you, you never miss any data. If you represent anything in a data model or something, you have the graphical or a tabular form of way, so you can make out that these data are missing and these things are missing in this. Okay, and what are the disadvantages? To develop the data model, one should know the physical data stored characteristic. You need to be aware of all the DBMS concepts. It needs actually like this is a navigational system procedure. This becomes complex. If it is in a normal graph like paragraph, you need not understand anything, you need not think about it, you need not like try to represent it as a model or a graph, anything. So that is computationally inexpensive if you are not using data model. But if you are going for data model, all those problems come in. Along with that along with that you get the advantages. Okay, so this is the basic advantage, and these are like some conclusions you can go through. So let me just give you one more call, like we'll move over to the next part. Okay, so the thing which I told you, the information model versus data model. Okay, so next, what is information and data? This is what, since we missed the previous class, I'm just trying to cover more in this class. So let me just give you one example of a company called SCME. One second. So let me just give you one example of a startup company, like company called ACME. So what it did was it started producing pencils and manufacturing pencils and releasing it in the market. Okay, so ACME Trading has started a business of selling pencils to its customers. Okay, so this is their first work they are doing. So what is happening is, this is the, when they do a startup company, so what they'll do, they have a ordering system. So what is that ordering system? They'll have two entities. One is your customer and the other is your order. Okay, so what happens is, in customer the attributes will be the first name, last name, discount, what promotional code you are using, what is the address line, what is the like zip code, city, all these details it will have. And the order entity will have the order number, order date, payment method, delivery date and status. So this is all about your ordering system. The relationship has to be like established between the customer and the order. Okay, so this particular thing will involve what, your customer like booking the pencil, and the pencil will be like packed, then shipped and delivered to the house. So this is basically the ordering system of any company. Suppose we manufacturing pencil or whatever it is. Okay, next comes when it goes to the growing stage. Okay, that was the startup phase of the company. Now when it goes into the growing phase, so what will happen is, they will try to grow their like customer build. Okay, so what they will do is, they initially had this customer system, where customer entity, where they had the first name, last name, all these details about the customer. Next, they will try to, in the previous thing, just see, when they were starting up, it was just the order number. Okay, order date. But now what they need is, now when they want to grow, they want the contact method, how to contact the person, so that in future if some new product they launch, they can approach these particular customers. So they'll have their mobile number, home number, work number, all these email IDs, every detail they'll try to store. So this is during the growing phase. Okay, so now what happens is, when they want to like extend beyond. Okay, so what will happen is, see, this is the growing phase. In growing phase, what will happen, the marketing strategy is a success, and ACME soon have to expand their operation. Suppose initially it was a success and they want to expand that, and need to develop their existing system to better handle the increased volume. Suppose the demand increases, so how they will go for, so they need to integrate this entire thing. So how they will do, they will introduce the information model. Okay, so how to get in information? Now see, I told you, data is any raw content is your data. Information means merging all those data, processing them is called as information. So in the grow like startup stage, just see, you had two data, like two information, the about the customer, you had all the information, about the order you had. When you wanted to grow, You had the information regarding the customer, you had the information regarding the contact method. Now when you want to actually grow beyond the capacity, so what you need to do is this particular data, this marketing system, this is the marketing system, okay. So this marketing system had some data, this ordering system had some data. You need to merge both of them. So how to merge, that will result in your semantics or the like integration of both the thing, which will give you information. So how to go about this information? See, the customer was there, the contact method, this was the marketing strategy, and this was your ordering strategy. So all three of them you combine and generate one information. So this obviously can be combined because in both the things your customer name and customer details were common. Okay, is it understandable? Can you understand whatever I am saying? Hello, hello, yeah, hello.
Yes,
So
ma'am.
Yes, ma'am.
okay, so what we did was we just merged the data of two different models. One was your ordering model, one is your marketing model. In ordering, you had just customer detail and this billing address, all those things. In marketing, you had customer and this contact method, everything. So all three, if you combine, it results in an information model. Okay, so this is all these theories are given. So next thing is going global. If the company, suppose the base was in India and it has already established everywhere in India, now it wants to go global. So suppose in Europe or somewhere it wants to establish. So what will happen is, suppose a Swedish company, suppose when the Swedish cell officers start sending requests to change back to headquarter, they are using the word KUND, okay, for customers. So they use the word kund for customer, and this for order they use this bestelling. Okay, this is the word in Swedish Sweden, they use this word for order. So what will happen is, now there is, for by making it global, you need to map your English word to the Swedish word. Okay, because you are trying to expand in Sweden. Now what will happen is that same information between English and Swedish now will be, see, the customer is now written as customer, at the below they have written KUND. So obviously if the company in Sweden uses it, they'll be able to identify they are talking about this customer, that KUND. So first name, last name, so all the Swedish counterparts of that is given. So obviously the order was there, contact method, address, everything gets merged together. Then you go for the information model, because the data model of different approaches have been merged, and finally you get something which is called as information model. So you can go through all these slides. When I share, I will share by today. So go through these slides, just try to understand the concept, that the difference between data and information model. Data model is something which is like raw contents are there, okay, which might not always have a meaning. But information model means you try to merge all the data or information, in data or raw content, to generate information. Some useful content can be inferred, which will be called as your information. Is it clear? Could you understand this much? Hello, I'll just stop recording here.